Okay, the figure shows a line with equation 9 minus x and the curve with equation y equals x squared minus 2x plus 3. The line and the curve intersect at points A and B, and O is the origin. Calculate the coordinates of A and the coordinates of B. So what I'm going to do is I'm going to solve these simultaneously. They are both in terms of y, so I can just equate them because at those 2 points, the y coordinates are equal. I take away 9 from both sides and add x on both sides, and I end up with that quadratic. And I factorized it, and x is equal to 3 from the first bracket, substituted it back, and I got y is equal to 6. So common sense tells me that's going to be the coordinates of B. And then x is equal to minus 2 from the second bracket. 9 take away -2 is 11, and that's obviously A. So those are the coordinates. Then B, it says calculate the shaded region R, right? That's bounded by the curve and the line. So the first thing I did was work out the area under the curve. So if you imagine a vertical line from going down from A and going down from B, it's that kind of shape under the curve that we're going to work out. It's always under. So I'm going to integrate that and put the limits in those on the ends of that square bracket. Substitute them in. Okay, make sure you get all the minuses right. You got to be careful, not careless here, because one tiny mistake is going to make the whole thing go wrong. I worked out the brackets, and look how I'm handling the minuses. And that came to 65/3. And then what I said, I needed the area of that trapezium. Now, from my y coordinates, it's 11 units high on one side, 6 units high on the other, and it's got a base of a 5. Well, it's not really the base. If you use a formula, you can flip that over with the 11 on the bottom. So the 5 becomes the height if you use the formula in that way. So I said the area of that trapezium was 11, add 6, divide by 2, and then times that by 5. And that's the area of that trapezium. So the shaded area is going to be the area of the trapezium, take away the area under the curve, and that'll give you the area of R, the shaded area. And I just did a takeaway with the calculator, and that's what it came to. Okay.